Boys and girls, so yesterday we listed these off. For those who weren't here, cost function was C of X. Average cost function was C of X over X. Marginal cost function tells us the cost of producing the next item, and that was C prime of X. What formula did we use to minimize the cost? Yeah, when the marginal cost function was equal to the average cost function, that's when we minimized cost, and that's what you were able to practice yesterday. Okay. So today we pick up with some other ideas, and now we're going to talk about revenue and profit. Sometimes the price function or the demand function, okay, is listed like this, but we call it P of X. So that's really what we should charge. As the demand goes up, the price goes up. As demand goes down, price goes down. As supply goes up, demand goes, well, as demand goes down, supply goes up, and yeah, so you see the relationship, right? Depending on what you want to talk about is the independent and dependent variable. But revenue function, let's just think about this for a second. This is what you got to conceptually think through right now. Okay, revenue is how much money we bring in. So let's say we produce X items, and the price is P of X. How much money did we bring in? X times P of X. That's your revenue function. We're going to call that equal to R of X. R. What do you think marginal revenue function would be? R prime of X. Okay, the revenue for the next item produced. So this was the cost of the next item produced. This is the revenue for the next item produced. Will be R prime of X. Okay, so we've got revenue, we've got cost. How do you find profit? Revenue minus cost. So profit function, large P of X, is equal to R of X minus C of X. The price is different than the profit. What do you think will be the marginal profit function? P prime of X. And now the question is, how do we maximize profit? I mean, that would be a nice thing to do, would it not? So let's do it, and let's just set up our equation. We know that profit for X items produced is equal to R of X minus C of X. If I want to maximize the profit, I should take the derivative and set it equal to 0. So let's do that. P prime of X is equal to R prime of X minus C prime of X. See what's going to happen? Set equals 0. R prime of X minus C prime of X. So, if you wanted to maximize profit, you could simply take your marginal revenue function, subtract your marginal cost function, and set equals 0 and solve. Or, another way to express this would be, whenever the marginal cost function is equal to the marginal revenue function, we have a maximum profit. That wasn't bad at all, was it? Pretty straightforward. Let's do it again. Prove it to your friend. 5 minutes, go. All right. C prime of X equals R prime of X. That is our maximum profit function. I'm sorry, maximum profit equation, not function equation. Let's use it. Flip it over. The formulas in the algebra are not hard to work through for these type of problems. However, understanding what you need at what point is difficult for people to think through. So let's just look at what it's asking us. Given a company has a cost function of C of X equals that thing, and has a price function of that, find A, we'll focus on A right now, the maximum profit for the company. Well, there's a lot of things you have to come up with in order to find maximum profit. For example, do you have your cost function? Right, we're going to need C prime. Okay, we know C of X. C of X is equal to 84 plus 1.26x minus 0.01x squared plus 0.00007x to the third. That's C of X. And in order to maximize profit, you know that you need to take the marginal cost function and set it equal to the marginal revenue function. So what is the marginal cost function? $1.26 We have 3 zeros in there. We multiply 7 by 3, we get 21. So that's my marginal cost function. I don't have marginal revenue. I don't have a revenue function. All I got is a price function. Very good. R of X is equal to X times P of X. Right? So all we need to do is take X and distribute it through P of X. So R of X is equal to 3.5x minus 0.01x squared. So R prime of X is equal to 3.5 minus 0.02x. So once again, what we're trying to do is we're trying to take R prime and set it equal to C prime, and that will tell us our maximum. I shouldn't say it will tell us our maximum profit. It will tell us production level that will give us the maximum profit. Okay, production level that will give us the maximum profit. So let's set those two equal to each other. 3.5 minus 0.02x equals 1.26 minus 0.02x plus 0.00021x squared. What to do, what to do, what to do. Those go away, right? What's 3.5 minus 1.26? So 2.24 is equal to 0.00021x squared. .24 divided by 0.00021. Square root. 103.23. So we have X is 103.28 items, whatever it is that we're producing. That is the number that we would be producing in order to have maximum profit. Did I answer the question? You gotta plug it in. Plug it in where? Yeah, so we gotta plug it into both R of X and C of X and subtract them. I mean, you gotta take. Remember that if we want to find P of 103.28, you gotta take R of 103.28 and subtract off C of 103.28. Go gadget calculator. Come on, there it goes. All right. Move it this way. I'm plugging them all in. So what I did right now is I plugged it into R of x. R of x was 3.5x minus 0.01x squared. If I plug that in, I get 254.81. $254.81 minus, now I got to figure out my cost. So now I'm going to plug that into 84 plus 1.26 times 103.28 minus 0.01 times 103.28 squared plus 0.12347 times 103.28 to the third. So you could also just plug this into your y equals, and then you'll go to your table and enter the values. It's up to you however you want to do it. Doesn't matter. 184.58. So 254.81 minus 84. Whoop, 184.58. Is that right? Thought I came up with something different when I did it earlier, but maybe I didn't. Okay. Maybe I'm just not very... You're right, Larry. I've always wondered what my problem is. Now I figured it out. Question. Yeah, when I did it earlier, I came up with 117. Anybody else come up with 117? All right. It's fine. Well, no, I was doing it real quick before class just to make sure I came up with an answer, but I came up with 117 here. Well, I probably didn't do the cost function correctly. I probably plugged it in wrong. So. Okay. Now, we got to go to B. And B is nice and easy. So that was A. Look at B. B says the production level at which the marginal cost begins to increase. Do you know what that's asking? Oh! Brooks got it. She's right. The inflection point. Let's think about this. The marginal cost function is the cost to produce the next item, right? The more items we produce, we hope that the cost to produce the next one will go down. That will be more efficient. So what it's wondering is, at what point does it start to go up? Somebody asked yesterday, how would that happen? I said, well, suppose you're making, 100 boots. And, you could fit 100 boots into a storage container. But as soon as you produced 101, you had to get a new storage container. Well, then obviously it's going to go up at that point. So we got to think about that. So you're right. We are looking for the inflection point. If the graph looks something like this, so to kind of illustrate Brooke's point here, she says, if this is the if this is the marginal cost, which is the rate of change or the derivative, you can see that the marginal cost is decreasing, isn't it? It's concave down. But all of a sudden, after you get to this inflection point, it starts to go back up. So we want to know that spot where the marginal cost is at its lowest and it starts to go back up. So all we need to find is the double derivative of the cost function. Production level at which the marginal cost begins to increase. So we need to find the second derivative of c of x. You already have the first derivative. First derivative is right here. Let's take the second derivative. C double prime of x is equal to what? -0.02 plus 0.00042 x. Set it equals 0, so you would have positive 0.02 is equal to 0.00042 x. Divide both sides by 0.00042, and we get x is equal to 47.63. Okay? Yep. No. So the idea is that we have, about 47 items is the point at which, we're most efficient. We are going to, kind of, it's going to be more expensive to produce each item after that, but maybe what we're most concerned about is the fact that this will maximize our profit. But it tells us something. It tells us something important. So, here you go. Your assignment. So, I want you 11 through 16, 19, and 20. As soon as you get your homework out and ready to go, we're going to do 20 together. If you got a book or you could grab one to share with somebody, that'd be great. There's one more. What is it? It's a necklace. Valentine's Day is coming up. What did I get for my wife? Going to Jared. I was telling my wife last night how much I spent for her ring when I first purchased it. When I got my first job teaching, I was getting married. My wife was still in school. After she graduated, we were going to get married. And my first year teaching, I lived at home with my family. And very common. You'll see a lot of people nowadays, they'll live at home because you have to get health insurance, everything else. Very expensive your first year out of college. But with my first year income, I did basically 3 or 4 things. Number 1, I did buy a used car that I could drive. 2, I paid for gas. 3, I bought a ring. No, for her. It was just a half carat, but it depending on the type of diamond you get, it could be really expensive. And the last thing, I saved up for a honeymoon. That was it. We went to Playa del Carmen. Playa del Carmen in Mexico. Yeah. So Riz got to go there just because I had to get married and save up my entire life to go there. That doesn't seem fair at all, does it? So, oh, family vacation. All right. Okay. Oh, really? Well, there you go. It's the place of romance, isn't it? What? Yep. Okay. Who can read off? Problem number 20. Larry, nice and loud. Read problem 24. It involves necklaces. Yep.
Get some cereal. Necklace costs $36. What should the selling price be to maximize profit?
All right, there we go. So, all right. Thank you, Larry. Larry, isn't it frustrating when people don't listen to you? Okay. Here you go. Terry's selling necklaces. So now we get to real world problem. And they're $10 a piece. And right now he's selling 20. Okay. But every time he raises it $1, he ends up losing 2 necklaces. He loses 2 necklaces. Okay. Yeah. They're like, I ain't spent $11 on a necklace, you know. Cheapskates. So Terry's got 2 options. He can either say, well, I'm just going to sell as many as I can for $10 and you know, just try to make the world a happy place so everybody can share their love on Valentine's Day. Or he could say, I want to maximize my profit, be like Scrooge. So that's what he wants to do. He wants to be a Scrooge guy, so that's fine. But we got an interesting dilemma here. We need to find the demand, and then we got to maximize the profit given the cost is $6 per necklace in order to make. So let's think about this. The demand function. If you notice, the demand function is really that price function, right? Okay. Well, if you want to find revenue, revenue is going to be equal to X being the number of items times P of X or the price. Okay? That's what we got. So let's think this through. Okay? Revenue is going to be the number of items times the price. Now, if you have trouble thinking this through, sometimes it's good to just kind of make a pattern. Okay? Right away, how many items does he produce? He produces 20 times what's the price? 10. Well, that was easy. Okay? Obviously, we're going to have a variable in here. So this is just, you know, when you don't know how to do the problem, just do the problem. So let's say that he takes that $10 and raises it by 1. Then the items goes from 20 and you subtract 2. Yeah. Let's suppose he raises the price by 2. Then he's going to decrease the number he sells by 4. So Larry's ready to put X in here, and I think we can do that. If we raise the price by X, Right, we decrease the number we sell by 2x. So, when it says what is the price function, or what is the demand function would be 10 plus x. Okay? The revenue function is 20 minus 2x times 10 plus x. Does everybody see that? Okay. So I've got that first part. Okay? Revenue function is right there. Now, so we did part A. Part A says what's the price function? Well, the price function is 10 plus x. You tell me the second part says I want to maximize profit. Is that correct? Profit is equal to revenue minus cost. So I need a cost function. How much does it cost me to build the bracelet or build the necklaces? $6. Does it cost me more if less people buy them? No. Does it cost me less if more people buy them? No, it's cost $6 no matter what. It's not like I get a deal on the parts for the bracelets just because I'm selling more or selling less. Okay, that could be the case, but not in this situation. Okay, so $6 times how many are we making? 20 minus 2x is what we are making. Well, we will. Okay? So, instead of actually, you got one way you can do this, which would be to actually, multiply this out, subtract them so you get your profit. But the other way, we know that in order to maximize profit, you have this formula. You could take C prime of x and set it equal to R prime of x. So let's multiply this through. We get 120 minus 12x, right? So what is C prime of x? Negative 12. In order to find R prime of x, I'm going to have to multiply this out. All right. Let's do that quick. What's 20 times 10? 200. I have 20 times x is 20x, and 10 times negative 2x is negative 20x, so that cancels. I have negative 2x times x. Okay, what's the derivative of that? Solve. Now, Larry, could you again read for us the last part of the problem so we know what it's asking for? Yeah. So we need to know the selling price. Does 3 tell me the selling price? No. The selling price is going to be 10 plus x, $13. $13. $10 plus x. 10 plus x was our demand function, our price function. That's it. So, you just got one word problem. It's problem 19. I gave you 19 so you could check in the back of the book, as you guys asked.